Welcome to part 6 of the Tri-Bucket project, and in this video I'm going to focus on refining the mesh, and to that in that direction I'm going to first turn off the buckets, and I'm going to hide also the bottom pieces, and we're going to look at the mesh and ways to create better meshes. In fact, it'll be better if I suppress the buckets, that way they won't be meshed, and I can even suppress the bottom soil. So we're only dealing with these 4 bodies for now, and this is what the default mesh looks like. There's a setting here where you can type in a smaller number, say 500 millimeters, and generate a mesh, and that will create smaller elements, and we'll see if we like the look of what we get. And if we don't, we'll take some other action. And so what you can see here is that you don't get small elements around the periphery of the boundary at the bucket. So we don't want this, and we'll go back to maybe a 1200 millimeter sized mesh, and that will we'll use other methods. So what we want to do is generate some mesh controls that we can put small elements around the circle here, and here's what we'll do. We'll use what's called a method on a body called sweep. So there is a body, the method is sweep, and the target is going to be this surface, so we pick face, and so it's going to sweep from that face to the other side of that body. And when we do that, we can inflate this method, and that means we want a boundary, and that boundary is this edge, and we might want 2 elements or 3 elements thick, and those elements will grow from the thinnest to the thickest, and we can tell what thickness we want those first elements to be. And so let's just look at what that does to this. So now you see it puts smaller elements near the boundary, and we can pair that up with one other mesh control for sizing on that edge, and we can apply instead of element size, number of divisions, and say we want 60 elements around that. And now if we generate a mesh, we can get some nice small elements at the boundary where the soil is interacting with the bucket. We might do the same, so we can duplicate that here and here, and we can also do it on this body here. So I'm going to just duplicate this mesh control, but I'm going to pick this body, and I'm going to pick this face, and there's actually 2 edges there, so I'm going to hide the body. I'm going to pick this body and hit F9 to hide it, so that I can pick this edge for sizing. And it's this sizing control has 1 edge, and I think there's a second edge there, so I'll apply that, and now there's 2 edges, so they both have small sizes, and we can inflate this method, and the boundary is this edge. and this one's got 5 layers. So let's take a look at how that has improved the look of this mesh. So we've got some very small elements growing out from the center. Perhaps we can set, let's look at the ruler, so view ruler, and look straight down and look straight in, and just pull that over to the ruler. So maybe 125 would be a good dimension for the first layer thickness, so we don't get it to be too small, and that's a control right here. Instead of smooth transition, first layer thickness of 125, and generate that mesh. And that's probably a better shape mesh for us. And we can repeat that on these other two. Let's hide the other two. Go to the body, pick the body, F9 to hide, and we just need to add to this inflation 2 more boundary edges. With the control key held down, after you pick something like an edge, it lights up green. You hold the control key down and you can add these 2 other edges. So now there's 3 edges that have that condition, and we can go to the edge sizing and hold the control. We pick the 2 edges, hold the control key down, and add in 2 more edges. Apply, and now when we generate that mesh, we might get something that's going to be a lot more useful for simulation, and that is starting to look pretty good. And if we look, we see we've only got 3 elements down through the length of the bucket, but this sweep method has number of divisions, and we can tell it no, we don't want 3, we want 30, and we can then generate that mesh. And we're starting to get some really good elements. The edge sizing of 60, maybe 120 to get even smaller elements. It all costs in terms of solution time, so you have to decide how small you need it to be, and there are what's called a mesh convergence study to look at how the results change as the elements get smaller, and that's always a good idea. But this might be something to use as a mesh convergence study, and maybe the global element size is still a little coarse. Maybe let's cut that in half and generate that mesh. And everything we do here on the topsoil, we want to do some of that on the bottom, but we potentially can have different meshes because we're bonding them together. They don't have to be identical meshes on the top and bottom, but that's starting to look like a fairly nice mesh for this model to get some more authentic results, more accurate results than the results we had with extremely coarse meshes, which were more to test out that we had the right boundary conditions and so on. So that's the outer piece of the topsoil, and if we show the rest of the pieces, we need to do those pieces as well. And but I think you've seen now the methods to create those. So this one is done maybe a larger first layer thickness, which is on this inflation control, and first layer thickness, well, total thickness, we are the first layer of 125, and if we look, it'll just update that. And there's a bucket between these two pieces, so they don't have to line up in any way. And that sweep of that body, again, number of divisions 30. So each body is going to be treated to get good elements, and I think that's good enough for now. Thanks for watching.